Okay, welcome to my YouTube channel. This is our fourth video in our tutorial series of YouTube comment prediction using machine learning. Just to remind you some few parts we covered in our previous tutorial video, which was video number 3 in our tutorial series. We covered how to split dataset into train and test set. Then we learned how to fit model. That's how to train or to put training dataset into model. So in this video we are going to cover only two things. Number one is to check the performance of algorithm, which is multinomial NB or multinomial naives by using cross validation and confusion matrix. So this tutorial video is just for determining the performance of our algorithm, which is multinomial naives. So as it is my methodology or approach of teaching, I'm using what, how, and why. So here we are starting with the meaning of cross validation. So the meaning of cross validation in machine learning is dividing dataset into k groups, then training algorithm by using training dataset, making prediction, then after counting or evaluating the total number of correct prediction. So in cross validation, as I've said, that it divide your dataset into k groups. I mean, if you have defined CV as 10, it means that it will group your dataset into 10 groups, make training, make prediction, then evaluate by counting the total number of correct prediction. So that's the meaning. So why do we use cross validation? We use cross validation if you have smaller dataset, or we use cross validation so as to get a better accuracy result as it predicts several times according to the number of V specified. So now is how we have defined the meaning of cross validation in machine learning. We have learned why we need cross validation, and now is how to do cross validation. So here there are some few libraries we need to import before we carry on. These are the libraries for determining the accuracy of machine learning algorithm. So in our first cell of Jupyter Notebook is where we import our necessary libraries which are used in our project. So we are going to import cross validation. So from sklearn from sklearn import, let's import cross validation underscore validation. Yeah, then after we need to import cross var_score, which will determine the accuracy. So from sklearn dot model selection underscore model selection import cross val score okay. That's for for cross validation. But as I've told you that our video covers two parts: determining the accuracy of a logarithm by cross validation, then determining the accuracy of a logarithm by confusion matrix. So we need to import a confusion matrix. So from sklen dot matrix, I hope dot matrix import confusion matrix confusion matrix. Yeah, so let's learn this cell to make sure that we have imported cross validation and the confusion matrix. So let's do this. From sklen dot matrix import confusion matrix. So what's wrong? Import confusion matrix. Oh, syntax. Let's run again. It should be confusion matrix. Let me see here a little bit. How we can import a confusion matrix. So let's see. This was my project, data science project in 2018. So it should be from sklen dot matrix import confusion matrix. Yeah, something like this. So let's close this Jupyter notebook. So yeah, I hope we are correct. Let me copy this. Let me paste it. So everything is correct. Possible there is a problem with Jupyter notebook kernel. So let me restart a kernel and run all cell. Restart. Now okay, I hope we are correct, but it was just the matter of kernel. You know, one of challenge in using Jupyter notebook is the problem of kernel. It frequently or always fail. So as long as you are doing your project on Jupyter notebook, you will have to restart a kernel several times. So that's it. We have imported cross validation and the confusion matrix in our first Jupyter notebook cell. So let's scale on. Oh, what's wrong? Matrix. It still have some problems. Let's run. From sklen import cross validation. From sklen what's wrong? From sklearn import cross validation. Let me copy this. As I've said that we have kernel problem in Jupyter notebook. So let's delete the first line even though they are the same lines. Let's learn once again. Still there is a problem. Let's restart and learn ourselves. Yes. Still cross validation. Oops. What's wrong? What's wrong with cross validation? Cross valscore. Let's delete the first line. We have imported it 2 times. Let's learn ourselves once again. Okay. Let's remove this line. Oops. Okay, let's learn this cell. I don't know what is happening with my computer. Okay, it's time to check the algorithm performance using cross validation. So V is equal to cross val score. Then we pass classification. This SLF is our multinomial knives by, as we stored it in a variable CLF. So cross var score takes about 4 parameter. It is algorithm. You want to cross validate xtrain or xtrain train dataset, ytrain and CV, which is equal to 10. CV, which is equal to 10, means that it will cross validate 10 times. So that's it. We'll need to use Python for loop to print how cross-validation have cross-validated 10 times. I mean, we are going to use the Python for loop to print the accuracy number 1 up to accuracy number 10 according to cross-validation. How cross-validation divided our dataset in 10 groups, train them and make prediction. So we needed to print the accuracy 10 times as we are doing cross-validation 10 times. So for I in range, put 10. Then we needed to print let's say accuracy of multinomial nice by is so the score is, let me put semicolon, is percentages sign then S. If you have done Python in formatting, percentage S is used to store a press or a space where number will be pressed during the outputting of your message. So this will hold for number which is accuracy of our algorithm. Then something like this. This is percentage. Then we need to format. We need only 2 decimal places. So let's put 0, 2, then percentage sign, something like this. Then here we should put dot format, then brackets, v, square bracket, I. Yeah, I hope something like this, if I'm not wrong. So let me run this cell to see what is happening. Okay, now oops, accuracy is, let me increase accuracy is of knife bias is, so let me see what's wrong with this. Is dot accuracy is, we need to, let me see what is missing. Let's remove this and put this double quote here and run this cell once again. Oh yeah, yeah, it should be something like this. Accuracy, oops, accuracy of knives by is 99%, 96%, 92, 99, 100%. Yeah, something like that. So the accuracy of nice by is, can't we remove this? Let's try to remove this. Accuracy of nice by is, oh, what's happen if we remove this? Accuracy of nice by is, yeah, this is perfect. So as you can see that we have finally cross-validated by getting 10 accuracy of our algorithm. So the first accuracy was 96, 96, 92, 96, 100, 100, 100, and so on. So which is actual or correct accuracy we need to consider. So it is advised that after making cross-validation by using for loop n times, we need to calculate the meaning of all of these accuracies we have got. So I'm going to print the mean accuracy, and thus is what I'll put more consideration. So yeah, here we are we are out of our loop, and let me display these words. The mean accuracy of knives by naive bias is, I need the mean. Let's say v dot mean. I hope something like this. Let's run this cell once again. Now you can see that the mean accuracy of naive bias is 96%, which is almost it wanted to be similar with normal accuracy, which was 97. So this is how you can cross-validate. It is one of the best way to measure the performance of algorithm. You cross-validate n times, then you find the total mean or the average of all mean you have cross-validated. So that's it. Just to remind you that so far we have covered the meaning of cross-validation, why we need it, and how to do it. So our next part is to learn confusion matrix. Also in confusion matrix, we are going to learn what the meaning of confusion matrix, why we need it, and how to do as my methodology of teaching. So by the definition, I can say confusion matrix is the just matrix which evaluates the accuracy of algorithm. It's the square matrix where rows and columns correspond to the list of class. Each row corresponds to the true class. Thus is confusion matrix, or you can call it error matrix. It shows the wrong predicted class. It means that it shows the mistake. What is the total number of mistakes were done in making prediction? For example, by definition, if we have I and J, in confusion matrix, is the number of observation actually in group I, but predicted to be in group J. I hope you got my concept. Means that something is predicted in the class which is wrong. That's why it is called the confusion matrix. It calculates the wrong prediction in a class. So why do we need it? That's the meaning of confusion matrix. Why we need it? We need the confusion matrix so as we can see the total wrong prediction of our algorithm, and it is one of the best metrics in sklearn. So we have covered the meaning of confusion matrix, why we need it. As I have said that we need the confusion matrix because it clearly shows the wrong predicted class. So we are going to do our last part, which is how can you or how can we do confusion matrix. So let's do it. Predict is equal to, let's start with fit is equal to our classification, which is multinomial naive bias dot fit. Then we pass x train and the y train, x train and the y train, yes, something like that. Then predict Confusion matrix takes two arguments or two parameter, which is actual value and predicted. So predict is equal to fit dot predict x test x test then C matrix confusion matrix is equal to confusion matrix confusion underscore matrix, then y test, then it predict. So this is how we can do confusion matrix in machine learning. C matrix. So we are going to learn this cell to print out our confusion matrix. Let me put a comment here, confusion matrix. Also here, let me put comment. This is called the cross validation. We cross validate several times in machine learning. So let's learn our cell to see the result. Or C matrix is not defined, C matrix. So let me run this cell C matrix. Let me run this cell. As I told you before that usually Jupyter Notebook have kernel problem. Let me run this cell. C matrix. Oops. Okay. C matrix. Okay, now we can see this is our confusion matrix. This is true positive, this is true negative, this is false positive, and this is false negative. So how can you determine algorithm performance in machine learning using confusion matrix? So we are looking for this diagonal. This is 47 and this is 55. So the total number of this diagonal should be greater than this. So here we have only 3 number of wrong prediction. So we can say our algorithm have better performance in training and making prediction. So I hope this is the end of our 4th tutorial in YouTube comment prediction tutorial series using machine learning. Just to make a short summary of what we learned. We learned the meaning of cross validation, which I said that it divides your dataset in a certain number of groups, train the algorithm, make a prediction, and count the total number of correct prediction. We also learned why we need cross validation. I told you that it is the better metric in machine learning because it trains algorithm several times so that we can get a good accuracy by taking the mean of all accuracy after cross validation. And we learned how to do. Also we have learned the meaning of confusion matrix, which is matrix help us to show the number of correct and wrong prediction. We learned also why we need confusion matrix, because we want to see how many mistakes are done by algorithm in making prediction, and we learned how to do confusion matrix. So that's the end of this tutorial. Do not miss our next tutorial in our YouTube comment prediction tutorial series. In our next tutorial, we'll learn about precision and recall, F1 score, R or C curve, which are also metrics for determining the accuracy of machine learning. See you in the next video. Do not forget to like, comment, and subscribe for next video update. Goodbye.